A and B are square matrices such that A to the power 5 is equal to I and ABA inverse is equal to B square, where I is identity matrix. If B to the power m is I but B is not equal to I, then find the minimum positive integral value for m. You are watching Brain Exploders, the world where brain starts working. So here is our solution. In previous video, we have discussed that not only identity or null matrix but infinitely many other matrices also exist such that they are square of themselves. Similarly, infinitely many matrices exist such that they are sixth power of themselves, or their seventh power is identity matrix, or some power of them is a null matrix, etc. These should not be compared with ordinary variable equations which have a fixed number of roots. It is given that fifth power of A is an identity matrix, so any matrix in the form of A to the power 5n must also be an identity matrix, but it is not necessary that A is also an identity matrix. And if any other power of A is assumed to be identity matrix, then it will contradict this given condition. For example, if we assume that second power of A is identity matrix but A is not, then A to the power 5 must not be an identity matrix. Thus, any power of A which is not a multiple of 5 is not an identity matrix. It is given that ABA inverse is equal to B square. Square both sides. In the case of matrices, power is not distributed to each variable. We can write ABA inverse times ABA inverse equals to B to the power 4. Matrix multiplication holds associative law, so we can multiply A with A inverse first. A times A inverse is an identity matrix which on multiplication with any other matrix give that other matrix as product. B times B becomes B square. Put ABA inverse in place of B square from the given condition. Again, on squaring both sides, we have 8th power of B equals to whole square of A square B A inverse square. Simplify it as previous and again substitute ABA inverse in place of B square. We get A cube BA inverse cube equals to B to the power 8. Similarly, we can obtain A to the power 5 times B times A inverse to the power 5 equals to 32. It is given that fifth power of A is identity matrix, hence A inverse to the power 5 is also an identity matrix. We get B equals to B to the power 32. On multiplying B inverse both sides, we find that B to the power 31 is an identity matrix, and now we can say that minimum positive integral value for m is 31. Let's move to our another question. Find the sum of following two series 1 minus 1 over 3 plus 1 over 5 and so on, and second series is 1 minus 1 over 2 square plus 1 over 3 square and so on. Try this question and comment us the solution, and if you have any question like this then please share with us. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.